Have you ever looked up at the night sky and seen a faint, fuzzy streak of light? Maybe you've wondered what it is or where it comes from. That could be a comet, a cosmic snowball, traveling through the vastness of space. These icy, dusty relics are leftovers from the birth of our solar system over 4.5 billion years ago. They're like frozen time capsules, preserving the original ingredients that built the planets and moons. Most of the time, comets hide in the distant Kuiper belt or Oort cloud, frozen and silent, far beyond the reach of sunlight. They drift in the cold darkness, waiting for their moment to shine. But sometimes, a gravitational nudge from a passing star or planet sends one hurtling toward the sun, beginning a spectacular journey inward. As it approaches, the sun's heat causes the comet's ice to sublimate, turning directly from solid to gas and creating a glowing coma, a cloud of gas and dust that surrounds the nucleus. Solar wind pushes this material away, forming the comet's iconic tails that stretch out behind it as it races through space. There are two tails, a dust tail that curves gently along the comet's path, sparkling with tiny particles, and a plasma tail that points straight away from the sun, glowing blue as charged particles interact with the solar wind. These tails can stretch millions of miles, creating a spectacular show in our skies, sometimes visible even to the naked eye. Comets are more than just pretty lights, they're ancient messengers, carrying clues about the early solar system and the origins of water and organic molecules on Earth. By studying them, scientists can learn about the ingredients that formed Earth and its neighbors, and even how life's building blocks may have arrived here. Each comet offers a unique story, a piece of the puzzle of our origins, with its own composition, orbit, and history. And sometimes, one of these messengers comes from far beyond our solar system, carrying secrets from other stars. That's when things get really interesting, reminding us that our solar system is just one part of a much larger cosmic story. Most comets we know are local. They orbit our sun, tracing paths that keep them tethered to our solar system. These comets return on predictable, repeating orbits, looping around the sun over and over again, sometimes for thousands or even millions of years. But 31 Poor Atlas is truly different. It's not from here at all. It's an interstellar visitor, born in a distant star system far beyond our own. This comet isn't bound by our sun's gravity. Long ago it was ejected from its home system, perhaps by a close encounter with a giant planet or a passing star, and has wandered the galaxy for eons, traveling through the vast emptiness between stars. How do we know it's not from here? Its hyperbolic trajectory is the key. Unlike the closed, looping orbits of local comets, 31 Atlas follows an open, hyperbolic path, meaning it's just passing through our solar system, never to return. When astronomers first spotted 31 Atlas and calculated its path, they realized they were witnessing something extraordinary, a rare tourist from another world, visiting us for a brief moment in cosmic time. That makes it a scientific goldmine, a sample from another part of the galaxy, delivered right to our cosmic doorstep, offering clues we could never gather otherwise. Studying it is like analyzing rocks from a distant planet or star system, all without ever leaving Earth. It's a unique chance to examine the raw materials that built other worlds. It lets us ask big questions. Are other solar systems made of the same stuff as ours? Do they share the same building blocks? Do their comets carry the same ingredients, water, organic molecules, and ices, that may have helped spark life here on Earth? 31 Atlas could hold answers about the chemistry that led to life on our planet, and maybe even elsewhere in the universe. It's a cosmic time capsule, offering a rare glimpse into the building blocks of distant worlds and the history of our galaxy. For scientists, it's a once-in-a-lifetime opportunity, a chance to study something truly alien and expand our understanding of the cosmos. This is why 31 Atlas has captured the imagination of astronomers everywhere, inspiring new questions and fueling the search for answers. It's not just a comet, it's a messenger from another star, carrying secrets from across the galaxy to our own backyard. How do we spot a tiny dark comet racing through space? With powerful telescopes, our giant eyes on the universe, massive observatories on remote mountaintops, like Mauna Kea and the Atacama Desert, scan the skies for cosmic newcomers. Survey telescopes take repeated images, and computers search for moving dots, potential comets or asteroids. Once a candidate is found, astronomers worldwide turn their specialized telescopes toward it. They determine its orbit, size, and composition. The key tool? Spectroscopy. breaking light into its component colors to reveal chemical fingerprints. Every element and molecule leaves a unique signature in the spectrum. By analyzing the light from a comet's coma, we can identify its ingredients from millions of miles away. This is how we hunt for water and other molecules on distant comets. It's detective work on a cosmic scale, and it's how the search for water on 31 Atlas began. The discovery of 31 or Atlas set off a global race among astronomers. The big question, does it have water? Finding H2O on an interstellar comet would be historic. To detect water vapor, astronomers needed infrared telescopes, like the James Webb Space Telescope. Observing a faint, fast-moving target millions of miles away is a huge challenge. The telescope must track the comet with extreme precision, or the signal is lost. JWST's sensitive instruments collected every photon of infrared light from 31 Atlas. The data was fed into a spectrograph searching for the telltale signature of water. It was a painstaking process, filtering out background noise to isolate the comet's faint signal, but the potential payoff, a glimpse of water from another star system, was worth the effort. After countless hours of patient observation, scientists meticulously analyzed the faint infrared spectrum streaming from 31 Atlas, a mysterious comet from beyond our solar system. The observatory was filled with anticipation as data poured in, each line on the screen a potential clue to the comet's origins. Their goal was clear: to search for water's unique chemical barcode, those bright, unmistakable lines at precise wavelengths that only H2O can produce. This signature would be the key to unlocking the comet's secrets. Suddenly, there it was, a series of sharp spikes appearing exactly where water vapor should be. The room buzzed with excitement as the evidence became undeniable. The observed pattern matched theoretical models for H2O perfectly, and no other molecule could account for these features. The data was compelling. To be absolutely certain, the team compared their findings to spectra from local comets and a variety of other molecules, ruling out every possible alternative. The match was clear and precise. This was water, unmistakably present in the data, leaving no room for doubt. This marked a historic milestone, the first direct detection of water in a comet, originating from outside our solar system, a true interstellar traveler. The water vapor was sublimating from a solid body. Ice formed in a distant planetary system, now journeying through the vastness of space to our own neighborhood. The excitement in the observatory was electric. This was a tangible piece of another world, made of the same essential ingredient as Earth's oceans and life itself. Scientists rigorously double-checked for errors, contamination, or instrument glitches, but the evidence remained solid and unshakable. The discovery was overwhelming, undeniable, and filled the team with awe at the cosmic connection they had uncovered. For the first time in history, we had found water on an interstellar visitor. The implications for our understanding of the universe and the possibility of life beyond Earth were truly profound. Confirmation required more than one observation. Other astronomers reanalyzed JWST data and used different telescopes to verify the water signature. Independent verification is the heart of science. Teams also searched for the byproducts of water, like hydroxyl radicals. Using ultraviolet telescopes, they found a cloud of OH around 31 Atlas, the smoking gun for water sublimation. The amount of OH matched the H2O detected by JWST. All the pieces fit, water was present and actively escaping from the comet. The case was now beyond reasonable doubt. The scientific community celebrated a global, collaborative triumph. So, what does finding water on 31 Atlas mean? It suggests the recipe for making solar systems might be universal. Water is essential for life, and now we know it's not unique to our solar system. 31 Atlas shows that water is likely common in planet-forming disks around young stars. This boosts the odds that habitable water-rich worlds exist throughout the galaxy. If comets deliver water everywhere, the conditions for life could be widespread. The discovery moves the idea of alien life from science fiction closer to scientific possibility. It doesn't mean we found life, but it means the ingredients are out there. Earth's story, water delivered by comets, life emerging, could be common. The universe may be far more friendly to life than we ever imagined, and it all starts with a single drop of water from a distant star. Comets aren't just icy, They're packed with complex organic molecules, the building blocks of life. Amino acids and other organics have been found in meteorites and comet samples from our solar system. This supports the theory of panspermia, that life's ingredients were delivered to Earth by comets and asteroids. The discovery on 31 Atlas adds an interstellar twist. These building blocks may travel between stars. Comets could be galactic delivery drones, seeding planets across the Milky Way. The atoms in your body were forged in ancient stars. The molecules may have arrived on icy comets. By studying 31 Atlas, we trace our origins not just to the sun, but to the chemistry of the galaxy. We are, quite literally, made of stardust and cosmic messengers. Our family tree stretches across the stars. The discovery of water on 31 Atlas is just the beginning. It opens a new chapter in our exploration of the cosmos. Each answer sparks new questions. Will the next interstellar comet be the same or different? Future telescopes will analyze even fainter, more distant visitors, mapping their chemistry in detail. Scientists dream of missions to intercept and sample an interstellar object up close. Imagine drilling into a comet's nucleus, unlocking secrets preserved for billions of years. This is the heart of human curiosity. We look up, we wonder, we explore. Discoveries like this remind us that the universe is full of secrets, waiting to be uncovered. 31. Atlas's fleeting visit has left a legacy that will inspire decades of research. It's a glimpse into another world and a hint that life's ingredients are scattered everywhere. Our cosmic quest continues.